Interference. We know that the two mechanical waves of the same frequency can interfere constructively if peaks of these waves are traveling in phase, and destructively interfere if the waves are not in phase. Similarly, light waves also interfere with each other as shown here. Light waves interfere only when the electromagnetic fields that constitute the individual waves combine. The interference pattern thus obtained contains alternate zones of maximum and minimum intensity called fringes. But if two light bulbs are placed side by side, no interference effects are observed because the light waves from one bulb are emitted independently of those from the other bulb. That is, they are not in phase. Thus, interference of light is the phenomenon of the non-uniform distribution of resultant intensity when two light waves from two coherent sources superimpose on each other. Thomas Young first demonstrated the interference of light in 1801. Did you know that the colors in soap bubbles, brilliant colors of the peacock feathers, and the colors that you observe when white light is incident on a thin film of oil floating on water is due to interference of light? The colors are due to the interference between light rays reflected from the front and back surfaces of the thin film of soap making up the bubble. The colors depend on the thickness of the film, ranging from black, where the film is thinnest, to red, where it is thickest. The multilayer structure of the feathers causes constructive interference for certain colors, such as blue and green. The colors change as you view a peacock's feather from different angles. The pattern of colors produced when white light is incident on a thin film of oil floating on water is due to interference of light. Variations in film thickness produce this interesting color pattern.